Now I will be proving Loucomb's theorem. Loucomb's theorem states that n factorial times the nth derivative of some function y is equal to 1. For this proof, we need to know several other theorems. Chunky-Chaudon's theorem assumes that we are ignorant non-calc students and states that y to the n is equal to the nth derivative of y. Ley-Gusak's theorem states that if an integral looks overly complex, it may be assumed to converge to 0. Chaudon's theorem states that the gamma of some function is equal to the Laplace transformation of the function upside down. Chaudon's theorem states that given some function f of t, where f of t is composed of fractions, f of t may be rewritten as a Chaudon matrix such that the determinant of the Chaudon matrix is equal to 0. Now, to start. We have that n factorial times the nth derivative of y is equal to 1, which can be rewritten as gamma of n plus 1 times the nth derivative of y is equal to 1. Now, take the partial derivative with respect to n at both sides. Using the product rule, we get the following. Using Leibniz integral, we can find the partial derivative of the gamma function to be this. Using Chunky-Chaudon's theorem, the nth derivative of y is equal to y to the n, and the partial derivative of this is y to the n times the natural log of y. This means we have the following equation. By Ley-Gusak's theorem, the first integral is too hard to solve and converges to 0. By Chaudon's theorem, gamma of n plus 1 equals the Laplace transformation of u plus 1, which is equal to 1 over s squared plus 1 over s. This can be transformed into the following Chaudon matrix. The determinant of the Chaudon matrix is equal to 0, so solving for s, we get s equals 0 and s equals 1. S equals 0 is extraneous, as dividing by 0 will get you arrested. Plugging s equals 1 back into the original Laplace transformation, we get the Laplace transformation of u plus 1 is equal to 2. Therefore, u plus 1 equals the inverse Laplace transformation of 2, which is equal to 2 times the delta function. Since delta of n equals 0 for every value of n besides 0, there's a 1 in infinity chance of a random value outputting infinity, and a 99.9% chance of a random value outputting 0. Therefore, we can assume that delta n is equal to 0. This means that u plus 1 is equal to 0, and that the Laplace transformation of u plus 1 is equal to the Laplace transformation of 0, which is equal to 0. Since the Laplace transformation of u plus 1 equals gamma of n plus 1, gamma of n plus 1 is also equal to 0. Putting these values back into the original equation, we get that the nth derivative of y times 0 plus the y to the n times the natural log of y times 0 is equal to 0. So, 0 is equal to 0. Since 0 equals 0 is a true statement, that means our original statement is also true. Therefore, n factorial times the nth derivative of y is equal to 1.